Hello, in the last video we talked about solving systems of equations using graphing. As you can see here, I've set up a system and I've graphed them. So I have a green equation here, blue equation here. I've circled the intersection, which is the solution. Unfortunately, the solution lies in between integers. You notice the x value could be 2.5, could be 2.4. It's hard to really say. And the y value looks like it could be 4.5 or 4 and 1/3. Can't really say. So when the intersection of the two equations happens in between integers, it's difficult to know what the solution is. So graphing in this case would not be the best way to solve this equation. Also, it can be tedious to have graph paper around. So graphing is not always the best way, and that's why today we're going to talk about solving systems using substitution. So notice at this point of intersection, the x and y values for the green equation are the exact same as the x and y values for the blue equation. We don't know what those values are right now, but we know that they're the same. So if I give you a new system here, notice we have two equations, 1 and 2. The y value and the x value is going to be the same in this equation as it is in this equation at that point of intersection, right? So at that point of intersection, the y and x values will be the same in both equations. Because of that, I'm going to rewrite equation 2 to say x plus, and instead of writing y, I'm going to write what y equals. So notice, this is the exact same equation as equation 2, except instead of writing y, I've written 3x. And the reason I can do that is because y equals 3x in this equation, so it must also equal 3x in this equation. Now the benefit of that is I can now solve this equation for x using the standard techniques we've been using for a long time. I can divide by 4, and now I know that x is equal to -8 at this point of intersection, right? Now I just need to figure out the y value, and that's pretty easy because I can just plug this x value into either one of these equations and figure out what y is. And so I'm going to do that to equation 1. So in equation 1, I'm going to write y equals 3, but instead of writing x, since I know what x is, I can just plug it in. It's -8. So 3 times -8, we all know is -24. So now I know the x value and the y value. And so the answer is -8, -24. And that's that point of intersection of the two lines, right? Now I can check this answer really easily, and I expect everyone in the class to do it as well. Mentally, -8 times 3 is -24. So that checks out with equation 1. It should also check out with equation 2. -8 plus -24 equals -32. That is true. Now if you check the answer into both equations and it's not true for both of them, then you've made a mistake somewhere. So then you can go back and try it again. Alright, let's do a new one. So here we have another two equations. We'll call them equation 1 and equation 2. And this one's not as easy as the last one because in the last one, equation 1 was already solved for y, so it was easy to plug in here. So in this one, we need to solve for y. So you can do it in either equation. I notice in equation 2, this y is all by itself already, so that's pretty nice. I just need to get rid of this -2x. And so that's what I'm going to do. So in equation 2, I am going to rewrite it first of all. And then I'm going to add 2x to both sides. And that leaves me with y equals 2x minus 3, right? We have a positive 2x and a -3 or -3. So now I know what y equals. It equals 2x minus 3. So now I have to put it back in the other equation. So I'm going to rewrite equation 1. But instead of writing y, I'm going to write 2x minus 3 because I know that y equals 2x minus 3. And plus 4x equals 14. Okay, so again, this is equation 1. instead of writing y, I just plugged in 2x minus 3. And now I can simplify and solve for x. So let's try it out. 3 times 2x, 3 times negative 3, and I have this plus 4x. Okay, so again, simplifying and solving for x. I'm going to combine these x terms to get 10x. And at the same time, I'm going to add 9 to both sides to get rid of this minus 9 here. So now I'm going to end up with 10x equals 23. Now I can divide both sides by 10. And I can get x equals 2.3. Okay, so now again, I can use this knowledge that x equals 2.3 to figure out what y is. I can put it into any of these equations. I'll pick equation 2 just because neither of them look terrific, so I'll just pick one of them. 2.3 plus y equals negative 3. Now I can do some multiplication here. Negative 2 times 2.3 is negative 4.6 plus y equals negative 3. Now I'm going to add 4.6 to both sides, and I figure out that y equals 1.6. And so now I have my answer. So 2.3 comma 1.6. Now this isn't really easy to check mentally. I mean, we can kind of ballpark it mentally. 4 times 2.3 should be a little more than 8, so somewhere around 9 maybe. And then 3 times 1.6 is probably somewhere around 4. 9 plus 4 is 13. So ballpark, we know that's at least close, if not right on, for equation 1. Equation 2, negative 2 times 2.3 is negative 4.6. Plus 1.6 would be negative 3. So it definitely works for equation 2, and we're pretty sure it works for equation 1 mentally. Now you could go so far as to actually do the calculation on paper for equation 1 just to be safe, but I'm thinking I'm pretty satisfied. Now we have a word problem here. As you know from the previous lesson, the whole benefit to making these equations is to be able to solve real life situations and word problems. So in this case, we have a snack bar that sells 2 sizes of snack packs. A large snack pack costs $5. A small snack pack costs $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? That's a lot of information, and it needs to be organized first of all. The first thing that I like to do is kind of identify what is unknown. Okay, usually the question they ask is one of the unknown things. How many small snack packs did the snack bar sell? So I'm going to say S equals number of small snack packs sold. Okay. Actually, I'm going to change that from an S to something else because my S's look like 5, so I'm just going to make that M. And then for another thing we don't know is how many large snack packs were sold. So I could say my L's look like 1, so I'll just say G equals number of large snack packs sold. Okay. So now that I have that information, I can make some equations fairly easily based on some information here. So I know that in one day, the snack bar sold 60 snack packs. Well, that's an equation, right? Because there's only 2 sizes. So we know how many small snack packs are sold, right there. We know how many big ones are sold, right there. If we add those 2 together, that's 60. So that's equation 1. We could call that the number of packs equation, something like that. Okay. We also know something about money, right? So we know that we made $220. Okay. Well, you make money by selling snack packs. So to make, so the amount of money we make from selling small snack packs is $3 per snack pack. So if we sell one, we make 3. If we sell 2, we make $6. If we sell 3, we make $9, and so on. And so what we realize is that if we just multiply the amount of money times the number that we sold, this is the amount of money we make from small ones. And this, in a similar way, is the amount of money we make from big ones. And so the amount of money from small plus the amount of money from big should equal the total amount of money. So we could say this is our money equation. Okay, so we're able to use these same variables for a number equation and a money equation. Notice M and G just represent the number of. Once you multiply it times money, that becomes money, right? So number of and money. So now we have our system of equations. We have equation 1, equation 2. We can use substitution to solve. So in equation 1, I can subtract G from both sides and get M equals 60 minus G. Now going to equation 2, I can just replace M with G. So I could, M with 60 minus G, so we get 3. Oops, let's use a different color there. So I get 3 times 60 minus G, right, because 3 times M, here's the M, plus 5G equals 220. And now I just simplify and solve for G. So let me move this down a tad. So 3 times 60 is 180. 3 times negative G is negative 3G. Plus 5G, because this is not being affected by the 3. Now I'm going to combine the G's. So I have 180 plus 2G equals 220. Subtract 180 from both sides and divide by 2. Now I know that G equals 20. Now going back up to this top equation, that makes that one really easy, right? If G is 20, M has to be 40. Okay, so I know that G is now 20. Let's put a different color there. So I know that G is 20, and that means M has to be 40. Now we can check it pretty easily. If I sell 40 small and 20 large, that's 60 total. If I get $3 for each small one, that's 120 right here. And $5 for each big one, that's 100 right here. So 120 plus 100 is 220. So that is correct. This is the answer. The actual question is, how many small snack packs does the snack bar sell? The answer is 40 small, right? So here it is right there.